Hello students and welcome to yet another video of foundation course of business statistics. In this video we are going to cover cumulative frequency distribution. We have seen frequency distribution, we have seen yes, we have solved certain problems on frequency distribution. Now let's study what a cumulative frequency distribution is. Cumulative frequency distribution is a way to understand how many values lie below or above a certain point in the dataset. Basically, cumulative frequency distribution is built on the regular frequency distribution. So let's take an example. Okay, so we'll 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 take a simple example, a toy example, but please. Okay, so this is our class. This is the frequency distribution F. Okay, so we have 10 to 20, 20 to 30, 30 to 40, 40 to 50. Correct? We have 4 classes. Now, if I ask a question, what type of classes these are? So the answer should be these are basically exclusive type classes. Let's take an example again. Dummy data. Okay, we have frequency 10, 25, 10 and 5. So total data points we have are 50. Now less than or equal to CF, where CF stands for cumulative frequency. So how should you calculate this less than or equal to CF? Whenever you are given less than or equal to CF, take this upper limit of the class and ask a question: how many data points are less than or equal to 20? I am repeating again. Ask question to yourself: how many data points are less than or equal to 20? 20 is my upper limit for first class. So immediately I understand less than or equal to 20, there are 10 data points. Now going to the next class, ask the same question: how many data points are less than or equal to 30? Now here less than or equal to 30 would be 10 from the first class plus 25 from this class. So this will be 35. For the third class, we will ask the same question: how many data points are less than or equal to 40? So these are nothing but 35 from the previous 2 classes plus 10 from this current class, that gives me 45. And for last class, my question is: how many data points are less than or equal to 50, which is nothing but 50 data points. Correct? So this is your cumulative frequency for less than or equal to type. Correct? So this is how you build the table. Let's move on. On the similar lines, you also have cumulative frequency for greater than or equal to type. Okay, let's take the same toy example and work out greater than or equal to cumulative type. So I have 3 columns. This is my class. This is my frequency F. Correct? and this is greater than or equal to CF. Suppose I have 20 to 20, 20 to 30, 30 to 40, and 40 to 50. As 4 classes, I have frequency as 10, 25, 10, and 5. Now I want to calculate greater than or equal to CF. Now here I will consider the lower limit of each class and ask a question: how many elements are greater than or equal to 10? How many elements are greater than or equal to 10? And you will immediately find out the answer. If total is 50, okay, how many elements are greater than or equal to 10? All 50 elements are greater than or equal to 10. How many elements for next class? How many elements are greater than or equal to 20? Now, in between 10 to 20, we have 10 numbers, correct? Now we are asking question, how many elements are greater than or equal to 20? So there are total 50 elements, but out of those 50 elements, 10 are between 10 and 20. So greater than or equal to 20 will be 50 minus 10, that is equal to 40. So here I will have 40. Similar, the question is, how many elements are greater than or equal to 30? Right? So what I have to do? I have to subtract from the 50 35, because 35 are less than 30. So greater than or equal to 30 would be 15. And last question, how many elements are greater than or equal to 40? So there are just 5 elements greater than or equal to 40. So this is my greater than or equal to cumulative frequency table. Okay, just see, it counts the observation greater than or equal to a given value, and that given value, okay, is for a lower limit of a class. Okay, in the previous example, that is for less than or equal to CF, we used upper limit of the class. For the greater than or equal to CF, we have to use lower limit of the class. Ask appropriate question to yourself, and you will be able to populate your cumulative frequencies without any problem. Please don't by heart these things. Understand it well, and you will be able to solve these problems pretty easily. Let's move on to next concept, and next concept is relative frequency distribution. So what is relative frequency distribution? Pretty simple. Let us take an example again. So if we have class, we have frequency, and we'll have relative frequency and percentage frequency. So let's give 10 to 20, 20 to 30, 30 to 40, 40 to 50. Frequencies are 10, 25, 10, and 5. So what is relative frequency? Total here is 50. So relative frequency is calculated as 10 divided by 50, 25 divided by 50. This 50 is the total number of data elements. Third is 10 divided by 50, and fourth is 5 divided by 50. So this is relative frequency. And what is the percentage? Percentage is nothing but relative frequency multiplied by 100. So for the first case it will be 10 by 50 multiplied by 100, correct? So it will be 100 by 5, so this will be 20%. This will be 50%. This is again 20%, and this is 10%. So this is how a relative frequency and percentage frequency are calculated. Very, very simple. Relative frequency is the frequency divided by total number, and relative frequency is just RF multiplied by 100. Let's move on to next. Okay, so similar to cumulative frequency, we can also calculate cumulative relative frequency. Let's see how we can calculate that. So another same toy example we'll take. So we have class, we have frequency F, and we have RF, which is relative frequency, and this is cumulative relative frequency. So 10 to 20, 20 to 30, 30 to 40, 40 to 50. If these are four classes, example 10, 25, 10, 5 are frequencies, total data elements are 50, relative frequency is, we know, 10 by 50, that is 1 by 5, that is equal to 0.2, 25 by 50, that is nothing but 25 by 50 is 0.5, correct? So 10 by 50 again is 0.2, and 0.1 is 5 by 50 is 0.1. Now this is 0.2, this is 0.5, this is 0.2 again, and this is 0.1. Now relative frequency is 0.2 for the first case, cumulative relative frequency. I just have to go on add it, 0.2 plus 0.5, 0.7, 0.9, and 1.0. So this is how my cumulative relative frequency is calculated. So we come to the end of this video. Thanks for listening, and we'll post the new video very soon. Thank you.